Yes, class. I hope I'm audible to all of you.
Yes, ma'am, you're audible.
All right, class. Yes, class. Sorry, at least for the month of Ramzan, this timings of class and Rosa here, these are clashing. So that's why it took me time to join. This is Faiza's and no, Rabia has already joined. Rabia and Humam and Tarif had attended classes. Faiza, this is your first class, right?
Yes, ma'am.
All right. So yes, what all many things we have covered in the last classes. Yes, Rabia, do you remember this concept where transfer of
Yes, ma'am.
particle occurs, Rabia?
Yes, ma'am.
Which is that elementary particle that transfers? Is it transferring of proton, transferring of electrons?
Transferring of electrons.
Electrons, transferring of electrons. So how does a body become negative? When electrons are gained into the body becomes negative, and when electrons are lost from the body, we say the body has become positive. So it's the transfer of electrons, as well as if the number of electrons and protons both are equal. If both of them become equal, we say the body is neutral. So that is the basics of electric charges, which you should remember. Apart from this, we have a procedure which is known as charging. Charging means transfer or the redistribution of electrons, because directly electrons do not travel, right? They, by a method, we can intentionally perform the transfer of electrons. So Tarif, do you remember what were the methods? Can you just name me the methods which we did?
Yes, miss. Charging by induction. Induction and conduction.
Induction, conduction, and friction. All right, charging by friction, charging by conduction, charging by induction. So in friction, we rub two objects. That allows the transfer of electrons to occur. In conduction, we do not rub objects. Movement does not occur. We just place both the objects in contact with each other like this. Transfer of electron occurs. In an induction is temporary electrification. I'll repeat induction because that was the last topic which we were doing. This friction you should know. Conduction, by now you should know how to solve identical one. Faiza, if you want, you can take the lectures of the last two classes because two classes have been covered. So if you want, I can send you the video lectures of this on WhatsApp so that you can tally up and see things. So let me know. Okay. In charging by induction, we have a neutral body having positive and negative charges which are balancing each other. Now, if I bring a glass rod, which is temporarily electrified, for example, it is holding positive charges. In this example, I took positive charges. So what did it do? It will attract all the negative charges towards itself. So what will happen? As a result, positive charges will keep aside, right? It's the negative charges only that will travel. Positive charges are static. Either they'll be accumulated because of repulsion of positive negative charges or by attraction of negative charges. In this case, positive rod is attracting the negative electrons towards itself, and rest of the portion, the positive charges left. So we can easily separate positive and negative charges which were in combination earlier, right? They were in combination earlier. Now we can easily separate it, positive and negative. We had seen a question also where we took an isolated sphere and made it positive. So same thing here also, but the problem just with this induction is that this is temporary electrification. And what does temporary electrification mean? Temporary electrification means till the time I'm holding this glass rod, till the time I'm having this glass rod with me, the negative charges and positive charges both are separated. So induction is occurring. As soon as I remove the glass rod, no, what will happen? Positive, negative, again they'll recombine. That will lead to neutral. Otherwise, in friction and charging by conduction, there wasn't such case. Once electron has transferred, once charges have been separated, then they'll be separated until and unless you do not manually shift the charges. In induction, charges get separated automatically, but they will recombine as soon as the inducing charge is removed. Then we had seen a procedure which is known as earthing. So as I've told you, earthing itself is a very important procedure. But for now, for this lesson, you should just remember this fact that either electrons flow from the body to the earth or from the earth to the body. This is what you should know. Why potential is zero, that we'll see in potential. That is the next lesson. So how to determine whether electron has flown from the body to the earth or whether electrons have come from the earth to the body to make it neutralize. If it's a negative body, electrons will flow from the body to the earth. All right. And if it's a positive body, then electrons flow from earth to the body. This much we had completed. We have to start with properties of charges. Under this topic, no, electric charge, properties of charges are there. Yes. So out of this, one property is very important, which I was mentioning. I'll discuss that in detail. Additive charges is very simple. What is meant by additive charges? See, electric charges are scalar quantities, right? So you don't have to consider parallelogram law, vector directions, and everything in your mind. If it is a scalar quantity, how will you get the resultant? Keep on adding it. For example, if I say this case, I have a sphere with me. The reason behind this is that they are scalar quantities only. So suppose I have a sphere with me, right? So +2, -2, +3, -1. What is the net charge? Net charge will be +2 Coulomb. So I can get the value like this, +2, -2, like this. To calculate the net charge, I can directly write it like this, +2 Coulomb, +3 Coulomb, -2 Coulomb, -1 Coulomb. I can easily write it. If had it been a vector quantity, let's say instead of charge, I would have taken electric force. I wouldn't just directly write it. So in case of electric charges, you can get the final resultant by simply algebraically adding all the charges. That is the additive nature. It allows the nature. It allows this property. All the charges allow the charges to get added up. Fine. So net charge on the body. This says that net charge on the body. This is basically algebraic sum of individual charges. That's it. This is that it is the algebraic sum of individual charges on the body. And one more thing, class, when I am writing, please do not write, just listen. I'll give you sufficient time according to your speed to note it down. So that is the first property, easy property. Second property is also very easy, conservative nature of charges or conservation of charges. This means what? The way energy is neither created nor destroyed, charges are also not created nor destroyed. It means you cannot produce electron from one body. By friction, you are not producing electron. We were just transferring electron from one body to another body. We were just transferring electron. We were not producing electrons. So you cannot create charges, but from one body to another body, charges can take place. So from the body from which the charges have gone, it will become positive and it will be a little less in number of electrons, right? But when you take the sum, when you take collectively both the bodies, the net charge will still remain the same. Even if one electron has traveled from here to here, what will happen? We will count that electron also. So this conservative nature of charges allows the charges just to transfer from one body to another. It doesn't get destroyed. Like friction force is a dissipative force. It could have been destroyed, but there's no such case in case of charges. All right. So second property is this additive nature and conservative nature. That's all what you have to remember. Invariance of charge is also a very simple property. Invariance of charge simply means that charge is independent of speed. This third property, for example, if I say there's a vehicle, there's a car, all right. This car has, the charge in this car is 4 Coulomb and this car is moving with a speed of 5 meters per second. All right, this is the initial case. Now what has happened? Now the car, it has increased its speed to 10 meters per second. Speed has been doubled now, right? Double the speed, 5 to 10 meter per second. But nothing happens on charge. The charge will still remain 4 Coulomb only for invariance of charge, because it is independent of speed. Charges do not depend on speed. So this basically shows the independent. This shows independent, that the charges are independent of speed. Charges do not depend on speed. So these three properties were very easy. Additive nature of charges, charges can directly be added. Conservative nature of charges, they are just transferred, they cannot be created nor destroyed. And invariance of charge, charges do not depend on speed. Fourth one is last one, that is quantization of charge. So this is a very important property. Do one thing, first note down the top 3 properties. Note it down, understand it. Any doubts you can ask, because fourth one, I want you all to have your full attention and do not worry about the writing part. All right, note it down. First note down this part. So from till here, you all have written, right? So from here, you have note. Done, class?
Yes, ma'am.
Done.
Yes, ma'am.
Okay, so yes, pay attention to this fourth property because questions are there from here. First numerical of your class 12 begin from this lesson, quantization of charges. See, very easy topic, very easy property. What have we discussed? One electron holds how much amount of charge? One electron holds 1.6 into 10 to the power minus 19 Coulomb of charge. This I have told you that, remember this value as well, the electronic charge. So this is 1.6 into 10 to the power minus 19 Coulomb. The electronic charge which is held by one single electron or a proton. Put plus minus according to the sign as we have discussed. For electron, put negative. For protons, you can keep on putting it like this. If I take 2 electrons, now what will be the charge? If for 1 electron, I have this much amount of charge. So for 2 electron, obviously it will get doubled. So this will become 2 into E, that is 1.6 into 10 to the power minus 19 Coulomb. So what I'm getting, 3.2 into 10 to the power minus 19 Coulomb. Let's take 3E, just the next number, 1E, 2E, 3E. Now what will happen? 3 times. If for 1 we have this, 2 we are doubling, for third 3 electrons, it will triple. So 3 into 1.6 into 10 to the power minus 19 Coulomb. This will be 4.8 into 10 to the power minus 19 Coulomb. Fine. So if we have, or let's take one more number, just take one more consecutive number, 4E. That will be 4 into 1.6 into 10 to the power minus 19 Coulomb. This will be 6.4 into 10 to the power minus 19 Coulomb. And I can keep on writing this 5E, 6E, 7E. I'll stop here. This much. Now tell me, class, amount of charge that is held by 1 electron is 1.6 into 10 to the power minus 19. Amount of charge held by second electron means 2 electrons, this is double of it. Then third electron, triple of it. If can I get a value in between these two? In between these two values, this value 1.6 into 10 to the power minus 19, 3.2 into 10 to the power minus 19. Tell me a number of electron that can exist which will have a value in between these. Can you answer this question? No. After 1, I have already taken 2. What is the number in between? And you cannot have half of electron, quarter of electron. That doesn't signify, no? Electrons are particles, right? They are just not describing entities. They are proper elementary particles. It can be 1 electron, 2 electrons, 3 electrons. So you cannot have 1/4 of electron in between it. So for 1, you have this value. For 2 electrons, you have this value. For 3, it becomes, see, this, double of this, triple of this, 4 times of this, right? So I can keep on extending it. So for n number of electrons, right? Charge will be Ne. This is what is the formula. Now, quantization of charge means that these charges, whatever all the observable charges that are present, they are integral multiple of this 1.6 into 10 to the power minus 19. This E, that's why I was saying electronic charge, you all should remember the value because it has a significance till the end. Even till your semiconductors, you'll be using this word, this value 1.6 into 10 to the power minus 19. This is 1.6 into 10 to the power minus 19 Coulomb. So all the observable charges, they are integral multiple. You can see 1 into this, 2 into this, 3 times this, 4 times this. This value is remaining fixed. So that is all what we say, where n is equal to 1, 2, 3, 4, and so on. So quantization of charges mean all observable charges in nature are an integral multiple of E, that is 1.6 into 10 to the power minus 19 Coulomb. So what is the formula? I was saying the numericals are there. Yes. And this formula, no, Q is equal to any class. This is a very small formula, very easy formula. But in your other questions, you will not be directly getting, you can get a question directly on this topic as well as in other topics in your electric field, in potential, in some other, wherever charges are included along with your 11th standard topics mix. You will be using Q is equal to any wherever this is required. All right, so it's a very short formula, but Q is equal to plus minus NE. This is a small but a very important formula that you should remember. So a question is also there. Let's start with this question. Calculate the number of electrons corresponding to 1 Coulomb. I have been telling you 1 electron holds this much amount of charge. 1 electron has a 1.6 into 10 to the power minus 19 Coulomb. This much I have been telling you. But what if reverse? So you will use Q is equal to any. Charge is given to you. What is charge given? Charge is given as 1 Coulomb. N, number of electrons, we have to find out. E is 1.6 into 10 to the power minus 19 Coulomb. Put it. So we want to find N will be Q divided by E. That is 1 by 1.6 into 10 to the power minus 19. This value will also be beneficial if you will remember 6.25 into 10 to the power 18. Because 1 by 1.6 into 10 to the power minus 19 is often used in the numericals. That you will see when you will be seeing questions accordingly. While using it, you will remember the value itself. 6.25 into 10 to the power 18. Specifically, it won't be asked, but in numericals, it can be used because, as I've told you, E has a lot of significance. One more question we'll do, but before that, note down everything in detail. Let me know if you have any doubts. Remember, this is an important property. Separate questions will be asked. And when the question is list the properties of charges, write all the 4 properties. Yes, Tarif, you can add. If a question is separately on properties of charge, though such types of questions have not been asked to write about the properties of charges. Basically, it uses the application of it, and especially this fourth, quantization of charges. But just in case if a question comes, you can definitely mention this point: charges repel and attract and types of charges. Plus one more numerical. This is very much related to your chemistry. So all the formulas of chemistry we'll be using in this. And this is a question from your NCERT only. And this is one single question that is given in such manner. Other questions are direct from your physics part only. So this says that calculate the number of electrons in 1 glass of water, and 1 glass of water is approximately equal to 250 centimeters cube. Now, a method to solve this question is, what is the volume given? Volume is 250 centimeter cube. And density of water. Yes, class. What is the density of water in CGS unit? Anyone? One. Remember this value, 1 gram per centimeter cube. In SI unit, that becomes 1000 kg per meter cube. In a CGS unit, this is 1 gram per centimeter cube. That won't be mentioned, class. Density of water. No, this won't be mentioned to you. This you have to remember by yourself, and wherever volume related questions, density related portions are asked, that you have to apply by yourself. Now, density volume. So we can find out mass. Right, what is density? Density is mass per unit volume. So mass will be density into volume, that is 1 into 250. So mass becomes 250 gram. Now, number of electrons. If you are able to relate it to your mole concept, no, of 11th standard chemistry, first lesson which you must have done. Number of electrons, number of molecules, these questions you must have calculated, you must have practiced. So same thing, same concept we are applying over here. So here what will happen? Same thing, number of moles in 250 grams of water. That means mass of water and molecular weight of water that we write. So mass is 250 divided by 18, this much moles. That's how we calculate number of moles. You have just come from class 11. So all of you must be remembering this very well. If still you're having doubt, let me know. I'll repeat this. So number of molecules, when we have to find, what do? We take the number of moles multiplied by Avogadro's number. That's how we get the number of molecules. So number of molecules in 1 mole will become 250 by 80, number of moles into Avogadro's number, 6.023 into 10 to the power 23, right? So I'll write this as 6 only, because then 6 and this will become 3. So this will become 8.3 into 10 to the power 23 molecules. So these many molecules are present where? These are present in 1 glass of water. So this is in 1 glass of water. And in 1 molecule of water, H2O, what is the number of electron that we write? What are the number of electrons? So number of electron, this is 8 for that and 2 for H, right? 8 for O and 2 for H, that is 10 electrons. So this is in 1 molecule. This is in 1 molecule of water. Fine, class. So how many molecules are present? 8.3. So number of electrons in 1 molecule of water, 10 electrons are present. So in 8.3 into 10 to the power 23 molecules, you will be having 8.3 into 10 to the power 23 into 10. That will be 8.3 into 10 to the power 24 electrons. I'll repeat the solution. So that's why I was saying this is more of your chemistry part, but this is given in your NCERT textbook. You have to prepare this numerical directly as it is. It will be, and it can happen, class. 1 glass of water is not mentioned in your NCERT also. No value that 1 glass of water is approximately 250 centimeter cubes. This is not mentioned. So if nothing is mentioned, take 250 centimeter cube in your board exams if it comes. If it specifies 250 ml, 300 centimeter cube, 500 centimeter cube, accordingly then solve with the same manner. So mass I have calculated. Using mass, I calculated the number of moles. So mass was 250 because what is the volume? Density is 1. Same way will be the mass. Number of molecules is 250 gram. And then I calculated the number of moles 250 by 18. Now number of molecules, how do we calculate? Take the number of moles, multiply it by Na. That is your Avogadro's number. You get molecules. So now you have molecules in 1 glass of water. So in 1 molecule of water, you have 10 electrons. So in 8.3, this much molecules, how many number of electrons you will have? Unitary method, you will multiply it. Is this question clear to all of you?
Yes.
Yes, ma'am.
Okay. Note it down, then this electric charge topic is over. How much time? Yes, we'll start with Coulomb's law. So note down this question with the solution. Any doubts you have from this entire electric charge topic, let me know. Now we have to move towards another topic, new topic. Class completed writing part.
Yes, ma'am.
Yes, ma'am.
Coulomb's law. Now Coulomb's law, this everything will now keep on building up. You have studied about electric charges. Electric charges will lead to electric force. Electric forces will lead to electric field, potential, all these. So basic unit you all now know. That is electric charge. Suppose if I take two charges. If let's say here I have one charge Q1, here I have another charge Q2. Fine. Be it positive, negative, that is not of concern to me right now. I have just taken two charges. Now see class, Coulomb's law says what? It tells you about the electric force, the formula of electric force, the magnitude of it, how to calculate it, what is the strength of it, and other associated quantities. If you take two charges, and let's say these two charges, what will happen if two charges are there? If both are positive, they'll repel each other. If let's say one is positive, other is negative, what will happen? They'll move towards each other and get attracted. So Q1 and Q2, these are two charges. They are separated, let's say by some R separation, R distance they are separated. Fine. So Coulomb's law says that 2 points, just remember 2 points for Coulomb's law. First point, the electric force magnitude is proportional to electric force. That is, you are calculating this force. This is directly proportional to product of magnitude of individual charges. Product means you are multiplying two quantities. That is Q1 into Q2. Product of magnitude of the charges. This means what? If I have 4 Coulomb with me and 2 Coulomb with me, product of magnitude of the charges will become 4 into 2, that is 8. But if in the same place, if I take 4 Coulomb and minus 2 Coulomb, product of magnitude is still the same. We do not consider the signs when we are taking the magnitude. So minus 2 coulombs you do not have to take. All right, in Coulomb's law, wherever you are considering Coulomb's law, be both the charges negative. Even if I am taking minus 4 Coulomb here, minus 2 Coulomb here. So magnitude of this component, this becomes 4, and the magnitude of this component, this becomes 2, this is still 8. So 4 into 2 is 8. It will remain whatever is the sign till their magnitude is 4 and 2, the final product will be 8. So this is the first point, product of magnitude of the individual charges. That is the first point. And secondly, the separation between the charges Q1 and Q2, they are separated by R. This is inversely proportional to square of it, not inversely proportional to the separation only, inversely proportional to the square of it. I'll show you. See, product of magnitude of the two charges means Q1 into Q2. And this is inverse square rule. Inverse square rule you must have studied in gravitation also, gravitational force. We write, no, same thing. This is very similar to it. G M by R square you write. Here also you will be getting some constant Q1, Q2 by R square. All right. Very similar to your gravitational force. So Fe, this is directly proportional to it. Now, how will I write it then? If I have to write down this, F is directly proportional to Q1 into Q2, their magnitude, divided by R square, because it is inversely proportional to the square of separation between them. Now, from mathematics perspective, if you have proportionality sign, how to remove it? Put an equal to with a constant. So equal to with a constant Q1, Q2 divided by R square. This is your formula. Apart from this also. Now, let us emphasize on this K. K this constant, this is actually written as 1 divided by 1 over 4 pi. Till this part you all are aware of what is pi, what is 4. One new quantity, that is epsilon naught. This I will tell you. So 1 over 4 pi epsilon naught is the value of this constant k, whose value, this entire value, when you solve, you get the value as 9 into 10 to the power 9. So what is the formula of force? That is 1 over 4 pi epsilon naught q1 q2 divided by r square. This is your formula for Coulomb's law. And again, this is a force. Can you tell me what should be the SI unit of it?
Newton.
Newton. It will be Newton because this is force. So be it electric force, be it gravitational force, any type centripetal force, forces have one single SI unit, that is Newton. So here also SI unit will remain Newton. Now coming to this epsilon naught, I hope rest of the things are clear now. Only one quantity we have not discussed out of here, that is this epsilon naught, this term. So what is this value? This is basically, we call this as absolute permittivity. For any medium you have, let me write it epsilon first. Epsilon naught I have removed. This dot 0 that I am putting in the subscript, no, that I am removing. Only epsilon. This is valid for any medium. Now first understand what is absolute permittivity, then epsilon naught specifically in these questions you will understand. Basically, epsilon means how your force is changing with respect to a medium. For example, look here class, I have this value, all right? So epsilon naught is certain value that is present in, let's say, air. I am getting a certain amount of force. I have changed the value of epsilon in the denominator. Force will also be changed. If epsilon, if anything in the denominator is changed, if anything here is changed, if this term, this quantity is changed, whatever is its definite value, I am changing this. The other quantity which is linked to it will also change. What will also change? That is, force will also change. If I keep both the charges in water, if I keep both the charges in, let's say, oil, if I keep both the charges in glass, I'm changing the medium. Force is also getting changed because it is the medium dependent property. And how it is depending on the medium, this is governed by this quantity. So this quantity governs dependency of the force on the medium. That is absolute permittivity, epsilon, only this E type of symbol. But when I put a naught, that is specifically, I'm specifying that the medium is air. There can be so many medium, no? But the most common medium is vacuum, air. So that's why I've specified epsilon naught is permittivity of free space. Here in the formula of Coulomb's law also, we use permittivity of free space only. That is absolute permittivity of air, epsilon naught. What is this epsilon naught? See, epsilon naught is the absolute permittivity of air or vacuum, that is free space. This also has a value again, which you have to remember, 8.85 into 10 to the power minus 12 Coulomb square per Newton. Coulomb square per Newton per meter square. Please. The way you, this will also be used and this will also not be given to you. So this is a very basic second thing that you have to remember at any cost. 1.6 into 10 to the power minus 19 electronic charge. Second, the value of epsilon naught. So by certain experiments, through certain experiments, this value was derived that yes, when two charges are kept, whatever, through experiments, that is not of our concern. We have come to a conclusion that epsilon naught means absolute permittivity exists. But if we say absolute permittivity only for air, the value is this 8.85. So what was the value of K I was telling you? 1 over 4 pi. Pi is 3.14. Epsilon naught 8.85 into 10 to the power minus 12. That's from where you get the value 9 into 10 to the power 9 Newton meter square per Coulomb square. So in your F is equal to K Q1 Q2 by R square. This K value is this 9 into 10 to the power 9. And what is elaborate form of this K? This is 1 over 4 pi epsilon naught. All right, so your complete Coulomb's law is this. In the questions, you can get one value of both the charges, separation between them. K, you have to put it on your own. So third quantity which you have to remember is K, 9 into 10 to the power 9. There will be so many quantities at the end of this session that you should list them. But these are so common, no? You'll be using it in every question that you will remember it by yourself. 9 into 10 to the power 9, 8.85 into 10 to the power minus 12, 1.6 into 10 to the power minus. I have been repeating it so many times that at least something you must be remembering it, right? So before we go on to the properties of this Coulomb law and all, this should be clear to you. Tell me any doubts if you have. The way Tarif does one thing well is that he texts me in the chat column. So all of you can do that. Text whatever doubt you have in the chat column while writing, because when we write, some doubt somewhere we get stuck. Otherwise, you can unmute yourself or ask, because this is a very basic and important topic. And not only from your class 12, those who have to appear for their entrances as well. Coulomb's law is a very important topic, and it is similar to your gravitational Newton's law, right? Inverse square rule. Note it down. Let me know if you have any difficulties. Yes, class, by now you must have written it.
Yes, ma'am.
Yes, ma'am.
Certain properties are there. These properties are very easy. These are properties of Coulomb's law. The properties which we did before this were the properties of electric charge, basic unit electric charge that we have. See, Coulomb's law, apply Coulomb's law only when you are sure that the spheres are present which are charged, or you have point charges. Otherwise, from this, Coulomb's law is not valid. See, class, you do not have derivation for this law. This is done experimentally. You also have to do it experimentally, and in your class 12 you all have the investigatory projects also. Many students take up this topic, so there also you have to have these small knowledge about these points. These points will be asked in your vivas only by the external. No, but nowhere you have to mention these points. So just keep in back of your mind that this is valid for only point charges and spheres. All right. Even if you have proper spheres which are unidentical, that is not of your concern. Even if you have 2 point charges, it is valid. And it is valid if both the charges are static or one of them is at rest. What is meant by the second property? See, this means that either it should happen that Q1 is static and charge Q2, this is moving in a circle. This is actually valid if it moves in a circle only. Because if one is static, other is moving with the distance remaining same. So that can occur in a circle only where radius remains same in every direction. So this is valid for circular motion also. This point, this property signifies that this is valid for circular motion as well. So Q1, Q2 both are present. Both are both can also revolve. Both of them should be at rest. This is valid. This I have been taking this example only Q1 and Q2 where both are at rest. But if one has to move, other one has to stay at rest, and the distance also between them should remain the same. If Q1 and Q2 are present, so it shouldn't happen Q1 and Q2 are right now here. Q2 has started moving and the gap has increased like this much. No. If Q1 is static, Q2 is moving, Q2 has to move in such a manner that this separation remains the same, and that is valid only for circle. So circular motion is allowed by it. One charge remains static, other moves with equidistance between them, or both should be static. Best is this. And mostly you have the static case also, but this can be used. And class, one very important hint for your numericals, because numericals also you will be practicing by yourself also. If you have the question where you are seeing one charge is revolving around the other, the way electrons they revolve around protons. What is that? Same thing, right? And the radii of the orbit remains same. In these questions, always divert your mind to the centripetal forces which you have been studying. mv square divided by r was the centripetal force in your circular motion of class 11th which you have studied. Always related with that. Usually it gets connected. All right, so if somewhere you're stuck in with the formula, this will be helpful. Yes, so conservative force independent of the path traveled. Conservative forces, work done is a conservative, where work done is constant or this is changing. Exact same thing what you have studied in your work energy and power. Exactly. Conservative forces, non-conservative forces. So conservative forces which are independent of the path traveled, they just depend on the initial and final position. So electric force is one of them. What were the non-conservative forces? Like frictional force, viscous force, these were the non-conservative forces. They didn't depend on the path traveled, right? So this is a conservative force. When we say conservative force, lots of things are allowed there. And it is a central force. It is a central force means this force always acts on the line joining, on the center of the line joining the two charges. Not exactly necessarily to act at the center. It means this will act when where the two charges are getting joined. Fine. These are the basic 4 properties which you should know. 1 or 2 numericals we'll do on this. 2 to 3 numericals at least we'll do on Coulomb's law. Some lengthy questions, some easy also. But for that, first note it down. Note down these properties and keep on texting me done when you keep on completing it so that I get an idea who has completed and who has not. Yes, Tarif. See, second point means that for Coulomb's law to be applied, where you have to apply Coulomb's law, one of the conditions you can say, or one of the properties you can say, is that both the charges, this Coulomb's law is a property of two charges. So both the charges should either be static, means both of them should be at rest like this, both the charges. Or if if motion has to occur, one of them has to stay at rest. This won't happen that both the charges are moving and you are also applying Coulomb's law. This is not valid. What I was saying regarding the circular point is that, see, when the other charge is moving, no, this charge is moving, the distance between them should not change. It should move in such a manner that the separation remains same. So if it moves in a circular path, what will happen? Radius will remain same. The radii in all the directions, this will remain the same. So it can cover circular motion, where one charge is centralized and other is revolving around itself. The way electrons revolve around protons. Protons are static in the nucleus and the electrons are orbiting in their shells, right? Similar thing. But it cannot happen that both the charges are in motion, both are moving, and you are applying Coulomb's law. Then you will not be able to apply Coulomb's law because it will not satisfy its condition. So either both of them should be at rest, that is the best thing. Or if one has to move, it has to move in such a manner that the distance is remaining the same. Is it clear now?
Yes, ma'am.
Just text me done once you have written, all of you. See, class, the numericals part and all, I'll do it tomorrow only. So prepare with it. At least revise what all we have done. I'll ask questions in the starting of the class. So at least just revise it. Regarding your Class, you must be having these assignments with you, right? So from Coulomb's law, at least try to attempt these questions. These 4 questions, these are sufficient. At least these you should attempt. Level 1 CBSE. Wherever difficulties you will have, you can let me know tomorrow, whenever we can discuss. So at least you will attempt questions before we discuss in the class. Some other questions I'll discuss in the class as well. Some lengthy questions. These are simple, easy questions. So at least first 4 questions you should attempt. All right. These first 4 questions. That's it. Just take out time and solve it. And class, again, the same thing. Here the timings will be clashing tomorrow as well, right? Here the Maghrib time is around 6:35 only here. And the class timing is also 6:30. So at whichever time I have started, I think it will take me 15 minutes. After 15 minutes, please join the class. All right. For me, it will be 6:45 to 6:50. 6:45 is sufficient. 6:45 to 6:50, the way I've joined it today. So at your time, it is 4. So 4:15, around 4:15, 4:20. Between this time, you all can join. All right, class. Thank you so much. Any doubts if you have, you can ask. Otherwise, you can leave. All right.
Yes, ma'am.
Thank you, ma'am.
Thank you, ma'am.